Hello everyone, my name is Alexandra Ortiz Martinez and today I will be presenting the key findings on redox-driven mineral and organic associations in the Jezero crater in Mars, and then this is homework 4 for Chem 1B. So first, we begin on a little background, the Mars 2020 mission. So we begin with the rover, right? So what is the rover? Its primary objective, it's simple, is to seek signs of ancient life in an area that we know was habitable. The team landed in the Jezero crater, a former lake, but our story today takes place in the Neretva Vallis, the ancient river channel that fed the lake. This is where they found a new target, a bright toned mudstone called the Bright Angel. So the primary goal of the rover was to collect the cache scientifically compelling rock samples for a future mission to return to Earth. Alright, and its primary objective was to seek signs of ancient life, biosignatures in a demonstrably habitable environment. Like I said before, the target was the Bright Angel Formation, a newly identified brightstone mudstone located in the Neretva Vallis. The strategy was to use a linked suite of instruments to map the large-scale geologic content, to prepare a clean, pristine surface for analysis, and analyze the microscopic texture, elemental chemistry, and molecular composition of the rock. So for the instruments and technique, the instruments that were discussed in the reading were the RIFMAX ground-penetrating radar, the Pixel plus MCC that analyzes Mars soil/rocks chemistry, the Sherlock plus Watson plus ACI cameras. This has UV laser to analyze Mars compounds, the SuperCam MatsCam Z, the gas removal tool, and its techniques were the surface preparation techniques, the UV rays, and the cameras and recordings. So for the toolkit surface preparation, first is the MatsCam Z, which you can think of as the rover's main eyes. Using its powerful zoom, the team identified the Bright Angel Formation from far away and confirmed it looked like a sedimentary rock, one that was laid down by water. That made it top priority target. And then we have the gas removal tool and the abrading bit. So for the gas removal tool, or the GDRT, it fires a precise puff of nitrogen gas to blow away all the loose dust. Think of it as of like a can compressed with compressed air. This was used on the target Chivaya Falls. And then the second one, the abrading bit, this is a grinder that scrapes away the top few millimeters of weathered rock to reveal a fresh, pristine circle inside. This was used on the Apollo Temple target. Only after the prep work can the real science begin. So the objective of the gas dust removal tool was to create a clean patch of natural rock surface for analysis. And then the objective of the abrading was to create a fresh, unweathered 5 centimeter wide circle to analyze rock's interior. Alright, and then for the micro-analysis trio, first we have Watson. This is the close-up hand lens. It is a microscopic camera that lets us see the fine-scale texture of the rock, just like a geologist would. The second one is the Pixel. This is the elemental mapper. It fires a tiny X-ray beam and can tell us exactly what the rock is made of, like iron, phosphorus, or sulfur, and where those elements are, pixel by pixel. And the third, we have the Sherlock. This is the organic hunter. It uses a UV laser that makes certain molecules glow. It is specifically designed to find the building blocks of life, organic molecules. And after we have the key findings, the leopard spots. So this is where everything gets exciting. So first, using the Watson and Pixel, the Watson camera moved and saw these kind of like leopard spots. You can see them in like circular features with dark rims and light bleached cores. The team immediately targeted them with a pixel, and the scan revealed that the dark rims were packed with iron and phosphorus. The light colored cores were packed with iron and sulfur. This was a huge clue. These weren't just stains, they were reaction fronts, tiny zones where a chemical reaction had taken place inside the rock a long time ago. And for the key findings for the fuel and byproducts, so we have these strange spots. And what caused them? This is the central finding of the study. The first, Sherlock, the organic hunter, scanned the rock and found organic molecules, quote unquote, the fuel of life, all over these spots. And then the pixel identified the specific minerals in the spots. So first we have vivianite, the iron phosphate, and then we have the greigite, the iron sulfide. This was kind of like an aha moment. The team found a direct correlation. Rocks with the most organic, quote unquote, fuel also had the most of these two mineral byproducts. It became clear the organics were being consumed to create these minerals. And then at the bottom of the slide, you can see the vivianite. It's kind of like green, kind of looks like kryptonite if you think about it. And then on the other side, we have the greigite. So for the hypothesis, this leaves us with two possibilities. First, the abiotic or non-living hypothesis. Could weird geology have done this? The problem is that one of these minerals, greigite, is very, very hard to make at the cold temperatures of Mars without a biological helper. It just doesn't fit the evidence well. This brings us to the biological hypothesis. On Earth, this is a classic sign of life. Ancient microbes ate the organic matter for food. Since there was no oxygen to breathe, they breathed the iron and sulfate in the rock instead, and as a result, they released vivianite and greigite as a metabolic waste. This hypothesis perfectly fits everything the instruments told us. For the team contribution, I used AI to help me create this image. You can see a representation of the oxidized mudstone, the vivianite, and the reduced zone, a biological scenario for the leopard spots. Microbes oil consume organic matter, reducing the iron sulfate in the mutone to form vivianite and greases, creating the bleached halo. For the conclusion, we have the finding. Our conclusion is that the rover's instruments from the broad mapping of the MATCAM-C or the microscope analysis of the pixel and the Sherlock have successfully worked in perfect concert. They have not found definitive proof of life. Instead, they have found something arguably more compelling, a complex potential biosignature. The significance of this is that this is not just one clue, but a pattern. We see the food, organic matter directly linked to the specific mineral waste products, vivianite and greigite, inside bleach reaction zones. This is a pattern that is very difficult to explain with non-living geology, but fits a biological hypothesis perfectly. The limit is that Perseverance, with its onboard tools, has taken this investigation as far as it possibly can. Its instruments have done their job. They found the X that marks a spot. And the solution, the definitive answer is now sealed in the tube, the Sapphire Canyon core, drilled from this exact rock and containing these leopard spots. Its catch on the Martian surface. The ultimate success of this hunt now depends on a future mission to return that sample to Earth for analysis in the most advanced labs. And to finish, this is my works cited, and I believe this is also interesting because this is all proof that there may be life on Mars. Thank you for listening, and I hope you have a nice day.